Again, I want it over. I don't, I just want a true answer, a real answer we can all believe in. Get it over with, get the millstone from around my neck, and let me go back to who I used to be. So I was excited, truly was excited. Gave him the sample, and he said he would contact me in a few weeks when he knew what was what. So, sure enough, he contacts me, and he says, well, it's amazing. It's everything you hoped it would be. The recovery was very easy. I've got dozens of sequences in the 200 to 2,000 range. And he says, I've sent many of those to the NIH, randomly chose parts to send to the NIH database, and the results are remarkable. Now, the NIH database is this: the National Institutes of Health is a large organization in the States that supplies the money to scientists who want to sequence genomes of all kinds of species. And since the 206, when the machine was invented, they just have proliferated. They sell them as fast as they make them. Boom, gone, to labs around the world that want them and want to be able to do this work. So within the States, if the NIH puts the money up, the report goes back to them and they own the report, and it's put into this giant database. So the last I checked, there were over 140 species types. It could be over 150 by now because they're adding new all the time, and there are thousands of species within those species types that have been sequenced, whole genomes. This is from viruses to bacteria to sponges to crustaceans to reptiles to gorillas to chimps, primates, monkeys, and humans. All of those genomes are in that database, amounting to trillions of what are called coherent base pair sequences, things that are understood. And they overlap too. Understand there's a lot of overlap of genomes within species. Like with the human species, a rat or a mouse is like 70% of our genome is in their genome. So there's a lot of overlap across the board. It's one of the great arguments for evolution, that you have so much mixing and matching of the DNA strands in different species. So the problem was, when he sent the Starchild sequences into the NIH database, a certain amount of them came back, a certain percentage of them came back as, sure enough, found in the human genome. They could find right where they fit, on what gene and what area. Very precise. And several dozen of those came back, so it was just no doubt that part of the Starchild is human, no doubt. But to their great surprise, and everybody's surprise, part of them, another percentage, came back not found in the database, meaning not found on Earth. I mean, that's what that means. What it says is not found in the database, but what you can project is it's just not there. So a large part of the Starchild genome is not found in the NIH database, which means it's not found on Earth. So that is a very strong indication that the Father's contribution is not from Earth. It's not human. It's alien. So everything that we thought about it, that we imagined about it, is actually going to turn out to be true. Now, it's important to understand that what we have recovered is a very, very small portion of the entire genome. We assume that the Starchild's genome is going to be in the ballpark of what a human genome is, which is about 3 billion base pairs. A chimp is about 3 billion base pairs, a gorilla is about 3 billion base pairs, but now a Neanderthal is proving to be substantially more. It's like 3.5 billion and pushing maybe toward 4, but much more than 3 billion, surprisingly. So the Starchild could be more than 3 billion, it could be less than 3 billion, but it doesn't matter if it's 5 billion. The 454 machines and now the Illumina machines, various machines, can recover it, the whole thing, and then we'll be able to compare it base pair by base pair, sequence by sequence, to human, to chimp, to gorilla, and to Neanderthal, and find out exactly where the Starchild fits in the grand scheme of life here. Now, what's really interesting about that is that a chimp is only 2 to 3% different from a human. A chimp's genome is 2 to 3% different. I'll just say 3%. We'll call it 97%. Chimp is 97% the same genome as a human. And all that separates us from a chimp is only 3% of the full 3 billion base pair, which is 90 million, 90 million base pairs. So that's a lot to work with if you know what you're doing, and there it is. So a gorilla is 5% different, so it's 95% the same. 150 million differences. So we assumed always that the Starchild, since it had a human mother and seemed to be a human-alien hybrid of some kind, we assumed that the father was going to be enough like a human so that it would fall within this 3% difference between a human and a chimp. That was always the assumption. Now, all humans, we are like 99.9% the same. You get some arguments now that it's a little more than that. It could be as much as 99.5. But wherever we fall, maximum it's like a 0.5% difference to explain all of the differences in the races, the heights, the intelligence levels. That's a very narrow window to explain all of that difference. But it's not 3% for a chimp or 5% for a gorilla. Those are pretty significant differences. So the assumption always was that the Starchild was going to fall in that 3% window. If it was a product of sexual union, it would have to, because it can't be a chimp, because a chimp and a human can't get close to producing offspring. It just can't happen. The chimps, all the higher primates, have 48 chromosomes and we have 46. So there's a problem right there. Not insurmountable. Other animals with mixed chromosomes can produce hybrids, but it's still, there's never been a chimp and a human offspring for whatever reason. And they've tried, the Nazis tried very hard to do that, to create a super soldier. So there's been a lot of attempts, no success. So the Starchild has to fall within this window, we think. And what I'm hoping is that rather than fall closer to the 99% mark, it will fall closer to 98, or maybe even closer to 97. The Starchild, if it falls up in the 99.5 or 99.4 or 99.3, that's close enough to human for scientists to say, oh, it's just some kind of aberrant, some kind of, like the Hobbit, just that's some kind of weird human that we didn't know about before, but it's still a human, right? But if it falls out to 98, that's too far. You can't really argue that's a strange human. It's just too far. If we're all 99.5 or less, out to 98, we win. This is an alien of some kind or other, human-alien hybrid. 97, well, then that's a chimp. Obviously, then it's an alien without even an argument. It's as different as a chimp is from us. You can't even make that argument. So when I was talking to the geneticist about what he was finding and the percentages that he was finding, I said, where do you think it's going to fall within that 3% window? And he just laughed and he said, it's not even going to be in that window. It's going to be well outside that. And I said, what do you mean? He says, based on what we're getting now, it's going to be between 10% and 50%. That's a huge, huge gap of possibility. But still, even if it's 10%, even if it's 9%, 8%, even if it's 5%, it's a gorilla. It's an alien. There's no argument that science can make to say that this is some kind of aberrant human if it's as different genetically as a gorilla. Now, another way to look at this in a kind of a reduced form is to imagine some lines here just in front of you. Imagine lines, and 100%, a full line is a human. Now imagine 3% in and you have a chimp. Imagine 5% in and you have a gorilla. Now imagine 10 to 50% and you have the Starchild. Now the Starchild we think is going to be in the range of maybe 15 or 20%. That's where it's looking right now, but it's a very ballpark estimate. But imagine this 100%, 97%, 95%, and let's go 15 and call it 85%. We're over to here. And let's understand that let's say a mouse is 70%. That's only 15% less of where we are at 85%. It's that different. A mouse has 70% of the human genome. So we're into a creature that's not even mostly human. It's incredible, because what it means is not only does the Starchild prove, or will the Starchild prove, that an alien human hybrid of some kind at some level existed and lived on Earth and died and was buried 900 years ago. That's a pretty big pill for science and everybody else to swallow. But that being that lived and died and was buried was genetically engineered. Could not possibly be the product of a sexual union, because you can't get that much difference between the two parents at that level. It's got to be genetically engineered to make that happen. That is a much bigger pill and a much harder pill to swallow. But that's where we stand at this moment, talking to you, doing this interview. That is where we think it's going to go. Now, when the genome comes in, however much it is, we may find some significant differences there in where we are now, because we are dealing with a small amount. If, let's just say, for example, that it's a 3 billion base pair genome, and let's imagine that as a loaf of bread. That's just a loaf of bread. We have maybe 30,000 base pairs recovered so far. That is a very thin slice off the end of that bread. Very thin slice off that loaf. Now, a slice, however thin, is enough to let you know that it's a loaf of bread, what it tastes like, what it's made of, what it smells like, what it looks like. But it really isn't enough to tell you what the whole loaf looks like or what the whole loaf is made up of. There may be ingredients and things that you can't really see, that you didn't happen to connect with. But we still have a good idea of what that loaf of bread is going to be like. And so we're extrapolating off of that amount. But when the final answer is in, it's without question, it's going to be beyond the 3-point or the 5-point window. But even if it isn't, if it's only 3% difference, if it's only a chimp, it's still an alien. If it's only a gorilla, it's still an alien. But if it's out where we think it's going to be, it's a super alien. It's beyond imagining almost, to the point where we're having a hard time figuring out how it could have been made. We're thinking maybe 3 parents are involved. It could be that its parents are both alien and somehow it came out of a human egg. It was implanted in a human egg and it was birthed by a human mother. Now, why that would happen, I have no idea. But that is what we're being pushed to make, those kinds of assumptions, those kinds of creative leaps of thought now, to just try to wrap our heads around where the indications are. So now all we really need is the money. Everything is lined up, everything is in place. We just have to get the money to do what we have to do. And I'll get it. Eventually somebody is going to recognize that this is history in the making, as big as history can be made. You know, it'll be bigger than, as big as or bigger than landing men on the moon. I mean, this is one of the pivotal points in human history when you confirm beyond a shadow of a doubt that alien life exists, and that it has been interacting with us for at least 900 years, and that it was capable of doing genetic engineering and sophisticated genetic engineering at least 900 years ago. That opens up the argument that human beings are genetically engineered, because there's a lot of evidence to that effect, that we are. In our genomes alone, we have the same amount of chromosomes as same amount of genome as the higher primates, but our chromosome count is different. They have 48, 24 from each parent. We have 46, 23 from each parent. Now, if that was in fact that all of that chromosome, those 2 whole chromosomes were gone, we could not have the same amount of genome. So what happened? Well, what happened is that in humans, the 2nd chromosome and the 3rd chromosome that are in primates, somebody somehow fused them together, took off the telomeres off their ends, took the ends off, put them together, and magically made them so that they absolutely continue to work.